Hello, welcome back to the channel. So let's do one more question on calculating integrals with trigonometric substitutions over here. So again, you have the same pattern over here, a square plus minus b square x square, in this case, which is the 25x square minus 4 expression. So that is why it gives us an idea that if we use trigonometric substitution in this case, we'll make our integral expression much more simpler than the original integral expression over here. And again, in this case, we see the expression 25x square minus 4. So if we take x to be 2 by 5 secant theta in this case, if we take our x to be 2 by 5 secant theta, 25x square will become 4 secant square theta, right? So if we take our x to be 2 by 5 secant theta, this term will become 4 secant square theta minus 4. And we already know a property about secant square and tan square, that secant square theta minus 1 is tan square theta over here, right? And in this expression, if we'll take our x to be 2 by 5 secant theta, we'll get 4 secant square theta minus 4. So 4 secant square theta minus 4 would be 4 tan square theta in this case, right? So let's do that substitution and see if we can simplify our integral in this case or not. So if we take our x to be 2 by 5 secant theta, our dx in this case would be 2 by 5 secant theta tan theta d theta, right? Because the derivative of secant theta is secant theta tan theta. So now let's plug in all the values of x and dx and do the substitution in this case. So our final integral will become under root 25 x square is 4 by 25 secant square theta minus 4 upon x is 2 by 5 secant theta, and your dx is 2 by 5 secant theta tan theta d theta in this case, right? So before simplifying this expression over here, we can clearly see that we can cancel this 2 by 5 with this 2 by 5. We can cancel secant theta with secant theta as well. So our final expression in this case would simply become integral 4 secant square theta minus 4 times tan theta d theta in this case, right? And again, this would be square root 4 times secant square theta minus 1 times tan theta d theta. And since we already know that secant square theta minus 1 is tan square theta, so this integral will be simplified to under root 4 tan square theta times tan theta d theta, right? So if we take the square root of 4 tan square theta, we'll get 2 tan theta times tan theta d theta, and this would simply be twice of tan square theta d theta in this case, right? And if you want to calculate the answer to this indefinite integral, this would simply be 2 can come out twice of integral of tan square theta d theta, and we know the property of tan square theta, that tan square theta is secant square theta minus 1. So 2 times integral of secant square theta minus 1 d theta, which would be twice of integral of secant square theta d theta minus integral of d theta in this case, right? And the reason why we converted tan square theta to secant square theta minus 1 was only because we know the integral of secant square d theta, right, which is tan theta. So this integral expression would be equal to tan theta minus theta. The integral of d theta is theta, and once you are done with solving all the indefinite integrals, you'll add the constant of integration at the last, right? And this would be your final answer. But in terms of theta, if you want to calculate the final answer to this indefinite integral over here, you'll have to convert your theta expression in terms of x in this case, right? And since we assumed our x to be 2 by 5 secant theta, our x is 2 by 5 secant theta. So we'll use the same approach to solve for tan theta and theta as we discussed in the last videos. Our secant theta, if we shift the 5 by 2 to the other side, our secant theta is basically 5x by 2. So theta is arc secant 5x by 2, right? Or secant inverse 5x by 2 in this case, right? And again, if we want to solve for tan theta, we know that our x is 2 by 5 secant theta. So we know that our x is 2 by 5 1 over cos theta. If we take the cos theta on one side, we'll get 2 upon 5x in this case, right? And we know that we'll again construct a right angle triangle in this case. So a right angle triangle over here. And now since we know that cos theta is basically base upon hypotenuse, so if we consider this angle to be theta, cos theta is base upon hypotenuse, so base is 2, this side is 5x, and now if you want to calculate this side using the perpendicular using Pythagoras theorem, this would be basically equal to 25x square minus 4 in this case, right? Which is simply under root c square minus b square. So now we have this side over here. We want tan theta at the end, right? We want the answer to tan theta. So if we calculate the answer to tan theta, we know that tan theta is basically perpendicular upon base. So perpendicular is this one, base is this one. So the value of our tan theta would be simply 25x square minus 4 upon 2 in this case. So now if you want to calculate the final answer, the final answer in terms of x, your final answer would be simply twice of under root 25x square minus 4 by 2, which is this tan theta expression over here, minus your theta is secant inverse 5x by 2. So secant inverse 5x by 2 over here, and then the constant of integration at the end. So that would be your final answer to the integral of this expression over here. And that's it for this video. Again, we followed the same approach which we were following in the last videos. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.